Today we're going to do an activity where we're going to attempt to find the coefficient of static friction between two materials. The first material will be a block of wood. The second material will either be the floor, or a desk, or a tabletop, or whatever we want, really. It doesn't really matter as long as you specify when you list your materials. Okay, so the problem in this would be to find the coefficient of static friction between material A and material B, whatever materials you use. And then, of course, your materials are, well, the two surfaces, okay, the block of wood, okay, the floor. What else are we going to use? Well, we're going to need to use a triple beam balance scale in order to find the mass. Okay, when we do this experiment, we're going to need to know what the mass of the block of wood is. So we're going to use the triple beam balance scale. We're also going to use the block of wood that you can see kind of in the corner of that picture right there. We're also going to use a mass set. I don't know if you can see it in the picture there, but there's a bunch of masses that are on top of that, okay? We're also going to use what's called a force meter, or a force sensor. And we're also going to use, this picture is a little outdated. Instead of using this, it's called an Explorer data logger, you're going to use the AirLink, which is attached to this force sensor, which of course the AirLink is going to beam it to your iPhone. So what else are you going to use? Your iPhone, or somebody in your group's iPhone. All right? What's a manipulated variable? Well, here's the way the experiment's going to work, and hopefully you can identify what the manipulated variable is after you see how the experiment's going to work. Same thing with responding, and same thing with control variables. You don't need to copy out the procedure per se, but you probably should draw it out or copy it out in point form so that you know what to do here. Essentially, you're going to take a block of wood. A block of wood is going to have a string on the end of it, and if it doesn't have a string on the end of it, by the way, then just tape a string to the end of it. It's going to have some masses in it. You're going to take a force meter, and you're going to pull that string with the force meter. But in order to actually measure something with this force meter, you have to have the force meter plugged into the AirLink sensor, and then the AirLink sensor synced with your iPhone so that you can read the data. Does that make sense? And you can see in this force sensor here, you can see that there's two holes. Those are for your fingers. Put your fingers in there. You literally hook it on just like this, and you give it a pull. There's a setting. Okay, there's a setting you may get when you click on your iPod, when you go into your iPhone, you may get a setting on the iPhone that asks you whether it's a push or a pull. Okay, if you do, you want to set it for pull. Does that make sense? Because you're pulling it, obviously. So if you get that setting, if you get that option, you want to set it for the pull. So here's how it's going to work now. You got it set up. You're going to give this a pull. You're going to pull it lightly until it starts moving. You're going to read the data on the graph on your iPhone, and you're going to read the data for the maximum force that was applied there. So your data might look something like this. Okay, you're going to have a graph of force versus time, and it might look something like this. It might look different. It's probably not going to be quite that pretty, actually, quite that uniform. But what you want to do, regardless, is take the maximum force. Okay? That's the maximum force that you applied to get it moving. That corresponds to the maximum possible force of static friction. Does that make sense? You've just measured the maximum possible force of static friction. Now, that's going to be on a graph. You don't need to email yourself that data. You can, but you don't need a bunch of different graphs from that. All you have to do if you want is have one of your partners write that down. So trial 1, here's the mass. Trial 1, here's the maximum possible force of static friction. Does that make sense? You can email it to yourself if you want, but you don't need to as long as you're writing down that number. There's nothing else from that graph that you're going to use other than the maximum force of static friction. Then you're going to repeat that experiment, but you're going to put more mass on or take mass off or whatever. Bottom line is you're going to change the mass of this. In other words, you're going to, and listen very carefully here because I'm going to answer a question that we asked just a minute ago. You're going to change the normal force. You're going to change the normal force here. And you're going to do that by changing the mass. Does that make sense? Each trial, you're going to change the normal force. And you're going to see how the max force of static friction responds to that. So you've done one trial, change the mass, therefore the normal force. See what the new force of static friction is. Okay, change the mass again, therefore the normal force. See what the new max force of static friction is, and so on and so on and so on. Okay, a little hint here. When you're doing this, it works better if you use heavier masses. Okay, these blocks of wood in themselves and the masses that are here aren't overly heavy. It should work okay. But if you've got more masses, like a set of keys that you can stick on top of it, okay, and so on and so on and so on, then it tends to work better if it's a little bit heavier. The reason being, you get a bigger normal force, it's going to be a bigger static friction force, which means you're going to notice it a little bit more when you go to measure it. That make sense? So you can use what's there, but if you find it's not working real well for you, then add some masses to it. You're going to record your mass for each trial, and you're going to record your maximum static friction. And then from that, you're going to calculate the normal force. And of course, the max force of static friction is still going to be the same value. How do you find the normal force? It's a flat horizontal surface. How are you going to find the normal force? Yeah, it's going to be the mass times gravity. So make sure your mass is in kilograms. Multiply it by 9.81. Just make it a positive value. Okay, just use positive 9.81 for it. Get the normal force and the max force of static friction. Then you're going to plot a graph. Remember, this is your data because this is what you're recording. This is your analysis because you're doing something with it. The graph is also analysis. The force of static friction, the normal force, you should theoretically, when you plot this, get a straight line. More or less, a straight line. The slope of that graph should equal the coefficient of static friction. This is the page that's important here in terms of getting the coefficient of static friction, but it's also the page that's important in order to identify your variables. Okay, remember, one of the variables, either manipulated or responding, always appears on the x-axis, and the other variable, either manipulated or responding, always appears on the y-axis. I'm going to leave it up to you guys to remember which one's which. So I'm telling you, Fn, Ff, one of them is manipulated, one of them is responding. You figure out which is which. Control variables? Well, control variables are pretty much everything else, right? There's a couple that are really important. There's 1,000 that you could list, but I'm expecting you to list 2 or 3. Okay, you want to get the important ones. And if you stop and think about it, you should be able to figure out what the 1 or 2 really important control variables are. At this point, you've got the coefficient of static friction. You're going to write a conclusion. There was no hypothesis for this, by the way. No hypothesis because, really, what are we going to hypothesize? The coefficient of static friction is, what are you going to guess? That's not a hypothesis, that's a guess. I don't want to guess to what you think the coefficient of static friction is. Okay, so your conclusion is going to relate back to your problem. Your problem says, what's the coefficient of static friction between this material and this material? Your conclusion is, the coefficient of static friction is blank. We know this because the slope of the graph is blank. And then, of course, you've got your sources of error. List 2 or 3 good sources of error, along with your ways to improve it. Right? Now, we're going to try again submitting this via Google Drive. Okay? I've started taking a look at the assignments that you guys handed in to me on the weekend and yesterday, and so far, it seems to work really, really well for you and for me. I know that a few of you are having a little bit of trouble submitting it. Okay, but once we get the hang of it, once I showed you how to do that, then it goes, it's so quick and it's so easy, and I have it in one place. There's no worries about me misplacing it. There's no worries about you losing it or misplacing it. Okay, and plus it saves some paper. So we're going to try doing that again. If you're one of those people that's still having a little bit of trouble with submitting that, then you need to come and see me so we can get that fixed up for you. Okay? Now, the one thing is with this one, there's not a template that I'm posting. Okay? I'm not posting this template on my Google Drive and then allowing you to use that template. So you're going to type this up yourself, and after you type this up, you're going to type it up on Google Drive, on the word processor on Google Drive, and then after you do that, you're going to share it with me the same way as you did the other day. The difference here is that you're not going to have to go onto my website to get something in order to do that. You're going to go straight to Google Drive and create a document and then share it after you're finished. You don't share it until you're finished, though, okay? Because I don't want to see a shared version that's not finished, and then I go to market and it's not finished and whatever, okay? So share it once it's finished. Is that good? Everyone's good? All right.